Good morning, dear students. Welcome back again for the next session of science, law of motion. Last time we have discussed about acceleration. Now today we are going to discuss about the graph of distance time for uniform and non-uniform motion. Now, how to understand what will be the graph for the uniform and non-uniform motion? In order to do so, here there is one observation. Here time and distance in meter, time in seconds and distance in meter is written here. For 0 seconds, distance traveled is 0 meter. For 10 seconds, distance traveled is 15 meter. For 20 seconds, distance traveled is 30. For 30 seconds, distance traveled is 45 meter. For 40 seconds, distance traveled is 60 meter. For 50 seconds, distance traveled is 75, and so on. And accordingly, it is plotted here. Now, time is plotted on the x-axis and distance is plotted on the y-axis. After plotting, see here, these are the plotted points. You can see here 0, 0. So this is origin. 10, 15. So here time 10 seconds and distance traveled is 15. Similarly 20, 30. Here time is 20 second and distance traveled is 30 meter. And accordingly we have to plot all the points. After doing so, we observe that when a line is drawn through all these points, we get a straight line passing through the origin. Whereas in other case, here see, time and distance is given here. Here time difference is same every time. A difference of 5 seconds is there. Here also every time difference of 10 seconds is there. Here difference of distance is 15 meter every time. Here difference of distance is not same. See here 0, 7, 12, 20, 30, 41. And accordingly we have to plot it here. After here time is plotted on the x-axis, distance is plotted on the y-axis. And now 0, 0, that is origin. 5 seconds 7 meter, you can see a 5 seconds 7 meter plotted here. Then 10 seconds 12 meter, 10 seconds 12 meter. Then 15 seconds 20 meter, 15 seconds 20 meter, 20 seconds 30 meter, 20 seconds 30 meter. Now plot all the points. Now after plotting the points, what do we observe? You can compare the graph. See, this is straight line passing from the origin. Is this a straight line passing from the origin? Of course not. It is little bit curved. This curved line indicates that this is not a uniform motion. In equal interval of time, equal distance are not covered here. Whereas here, in equal interval of time, here equal interval of time is there, equal distances are covered. And therefore, here we get a straight line from the origin, and here we get a curved line from the origin. So here, conclusion here, for the first graph, the graph of uniform motion is a straight line. Time and distance are proportional. The graph indicates time and distance are proportional. Second graph, you can see here, non-uniform motion is not a straight line. Here time and distance are not in proportion. This was a two graph about the uniform and the non-uniform motion. Now we'll be dealing with another graph. This time it will be of velocity time graph for uniform motion and velocity time graph for uniform acceleration. Like in the previous year also, observation and the graph is plotted so that you can understand very easily. Here a train is moving with the uniform velocity at 60 km per hour for 5 hours. Means that every hour with a speed of 60 km per hour it moves for 5 hours. And therefore you can see the graph is a straight line, linear line, not from the origin but from 60, straight line. See here, speed, this is y-axis which indicates speed, velocity kilometer per hour. X-axis indicates time in hours. Here 1 hour, 0 hour, 1 hour, 2 hour, 3 hour, 4, 5, 6, 7 hour. And here speed 10, 20, 30, 40, 50, 60. In the initial hour it was speed is 60 km. First hour 60 km per hour. The next hour also 60 km per hour and so on. The speed is constant. With the help of this graph, we can find out that within a given time how much distance was being travelled. Here when a line is drawn at A to C and B to D, so we can find out that between second hour to the fourth hour how much distance was being travelled. Definitely it is 120 km was being travelled. So this is the advantage of this. Further, again one more is there. You can see the observation table here. Time and velocity 0, 0. Time 5 seconds, velocity 8 meter per second. Time after 10 seconds, the velocity is 16 meter per second. After 15 seconds, the velocity is 24 km per second. After 20 seconds, the velocity is 32 meter per second. After 25 seconds, the velocity is 40 meter per second, and so on. Here on the x-axis, we have to plot the time in seconds. On the y-axis, we have to plot velocity in meter per second. Don't forget, whenever we are drawing graph, we have to write the scale also. Without proper scale, it is very difficult to plot the graph. So here, what is being observed? That after equal interval of time, the change in velocity is also constant. So with a constant speed, after regular interval, the speed is continuously increasing, and therefore a graph is being plotted or formed which is straight line from the origin. The conclusion from the first graph is that distance between any time can be determined very easily. There is a relationship between distance covered and area of quadrangle. You can see a quadrangle is formed A, B, D, C. The distance covered will be equal to nothing but the area of this quadrangle. Similarly, we can do it for the second graph also. Graph 3 also implies uniform motion. Now graph 4 implies uniform acceleration. The velocity changes by equal amounts in unequal time interval, which implies that uniformly accelerated motion, which also gives implication about velocity time graph is a straight line. Non-uniformly accelerated motion may not have any shape. Here there is a straight shape from the origin, but in case of non-uniform motion, you may get any curve depending upon the accelerated motion. in order to find out the proper distance here, in the case of fourth graph, to find out the distance, we have to use the formula of average speed and time. See here how to calculate the average speed. Average speed between 10th second and the 20th second is 32 plus 16 upon 2, which is nothing but 48 upon 2, which is nothing but 24 meter per second. So now the speed is 10, and therefore multiply by 10 here, and the total distance covered between 20th second to 10th second to 20th second is 24 into 10, that is nothing but 240 meter. Here also there is a relationship between area covered and the quadrangle formed. What is that relation? Area of quadrilateral ABCD will be equal to area of quadrilateral AECD plus area of triangle ABE. That's all for today. Have a great day.